طيب بسم الله الرحمن الرحيم. Okay, so we finished this slide. We talked about wireless security, and we talked about some properties in wireless networks that makes or creates more security threats that we have not been introduced to in the wired networks, mainly because of the physical properties of the wireless medium being a broadcast environment, and all signals are traveling through the air. The other thing is that in order to connect to any wireless LAN, you have to perform some kind of discovery phase. You have to perform some association to the access point. These two phases did not exist before in wired network. In wired network, it's a physical cable. You connect and off you go, right? You don't have to discover anything. You don't have to associate yourself to a particular access point. Why? Because in wireless, you may have 2-3 access points in the same neighborhood, right? So which one you should connect to? So if you say Wi-Fi, you get many networks, right? So which one do you connect to? So this association phase did not exist in wireless, in wired networks, right? So based on that, many of these threats have come about in wireless environment that did not exist in networks, right? So the principal threats to wireless transmission are eavesdropping. Of course, eavesdropping is really very common, and it's inherent in any wireless environment. In wired, it's a little bit hard. Why? Because you have to get in the middle of the wire in order to eavesdrop, right? Or in multi-access LANs, you have to connect to the switch. But connecting to the switch might not be facilitated or something. But if you connect to the switch, then and only then you can eavesdrop. But in wireless, anywhere you can eavesdrop. So to deal with eavesdropping, two types of countermeasures are appropriate. So especially targeting بقى فكرة الايه discovery and association phase ده. So of course, because of the fact that in order to connect to wireless networks, you have to discover 95% of all Wi-Fi LANs, they have to really make themselves discoverable. In other words, the access point needs to broadcast its name and its SSID and all of this, right? And 95% of the time, the access point even sends its own MAC address. And you have to know all this information in order to perform association. Okay? But this will make the wireless LAN exposed to everybody, and you don't know whether this person is really internal in the organization or maybe someone coming from outside, right? So one of the measures is really to work on signal hiding techniques. So I need only people who know the internal environment to be able to associate themselves to the wireless LANs. Anyone coming from outside, he or she should not be able to connect to this wireless LAN easily, right? So either we turn off SSID broadcasting, okay? We can do that. So the SSID broadcast will be disabled, which means that if I want to connect to this wireless LAN, I should know the SSID. We're not going to tell it to you. If you are internal in the environment, you should know it. And in the Wi-Fi settings, you can say connect manually, and you enter the SSID. Okay? So that's one thing, which is easy. Assign cryptic names to SSIDs also, and then you have to do some kind of authentication to the SSID in order to be able to connect to it. Reduce signal strength. That's interesting. Reduce signal strength. This will do what? This will limit the scope of the wireless LAN, right? If you reduce the signal strength, if you reduce the power, معناها you reduce the domain of the wireless LAN, right? معناها ان انت you are reducing the risk, right? So the wider this domain is, the higher the risk of the fact that someone from outside can connect easily, which is what we talked about. اللي هو ال occasional association. يعني someone is passing by the university, but the signal is really very strong that it goes outside. Someone is passing by the gate of the university, he can connect to the wireless LAN of the university. Okay, by mistake حتى يعني. Okay, we should not really let this happen. Locate wireless access points in interior of the buildings. That's again, it's related to this. So in order to reduce the risk of people from outside connecting to the wireless LAN, locate the access points internal, okay? But make the signal strength outside very low so that no one from outside can connect to it. واضح كده؟ ماشي؟ طيب. So that's regarding the signal hiding or reducing the domain of the wireless LAN. There is, of course, the measure when it comes to encryption and authentication, which is what we are going to talk about. Okay, this is the main topic around which we'll talk in the remaining part of this chapter. Denial of service can also be countered. احنا قلنا denial of service in the case of wireless can get as low as the physical layer, right? Through jamming, برافو عليك. Through jamming, right? Only by knowing the frequency range that this access point accesses, I can jam this frequency range, okay, and get the access point inaccessible to anyone, right? That can be done. Type. What are the countermeasures? There are countermeasures, right? Some access points sometimes. So that depends on two things. There are two types of denial of service attack when it comes to jamming. There is the unintentional one, okay? And someone in the range of the access point, he's using the same frequency range to communicate with another node or another access point. But it happens that this communication uses the same frequency range that this access point uses. Okay? That's unintentional. So I'm not targeting really to attack, but it just happens by coincidence that I'm using the same frequency that this access point uses. So in that case, denial of service becomes interference. يعني. So I'm causing some interference on the wireless communication of this access point. Okay? طيب, how can I countermeasure this? I can really do site surveys. So these access points, actually, they have built-in functionality that it surveys all the frequency ranges frequently. Okay? And then it finds the frequency range that has the lowest level of interference. Okay? And then it uses that range for communication. ماشي كده? So when it broadcasts its own SSID, it says that these are the channels that are available that I can communicate with. I can communicate over these channels. I don't use these channels, I use other channels. Why? One of the reasons is that the other channels are currently occupied and it causes lots of interference. So I can do that. But this is to address the unintentional interference or the unintentional denial of service. Right? But there is, of course, اللي هو intentional one. اللي هو بقى someone is really jamming on purpose. Okay? There are still also countermeasures to do that. Okay? So sometimes you can change your range of frequency frequently. Okay? So you can do some kind of maneuvering. ماشي? In all cases, you can do that through site surveys, you can do that through continuous measurement, and that's why these access points, as we said, this access point has lots of functionalities. From the physical layer point of view, it has to always continue measuring the signal strength in different frequencies. And then it takes decisions automatically to move from one range to another. And then it has to perform, as we said, for network injection, it has to perform something we talked about last time, اللي هو traffic filtering. We need to filter traffic. I don't want to allow anyone to send مثلا routing information through the access point because routing information should not be allowed, right? So the access point has to do lots of things. Again, all of this, the switch doesn't have to do. Switch is easy, but these access points have to be very, very small. طيب. Now we're going to talk about dividing these countermeasures into two things. There are some things related to the access point, and there are some things related to the mobile device. ماشي؟ طيب, the main threat involving wireless access point is unauthorized access to the network. As we said, someone is trying to access the network by doing association, either accidentally while they are not real, or they should not be part of the network. Okay, they just happen to pass by, مثلا, and they connect accidentally to the access network, or somebody who's actually really malicious and he's trying to perform some attacks. So in order to prevent that, we have talked already about this standard, right? This is a network access security protocol, which is used to tunnel the messages of authentication. So 802.1x, together with the extensible authentication protocol, right, can be used to send or facilitate handshaking between any device and the wireless or wired, right? So these are valid for both. But as we said, for wireless, there are two phases that did not exist in wired. ماشي؟ اللي هم discovery, how to discover the wireless network, and how to associate yourself to the wireless network. These two phases did not exist before. But the authentication is part of it. And of course, authentication is a prerequisite to key exchange. So we have the phases are like this. In wireless, we have discovery, we have association. These did not exist in wire. ماشي? 3, we have authentication. Yeah, this one we talked about. And then 4, key exchange. Those two, they existed in wired network. We know how to do this using EAP and using اللي هو الEAP OL or the 802.1x, okay, to tunnel the messages, regardless of the message of authentication, whether it's IKE or pre-shared key or whatever. Then we know how to do this, right? The problem in wireless is these two. Okay, these need to be arranged or resolved. And that's why we need other protocols to deal with that. ماشي? So the 802.1x, it provides an authentication mechanism for devices wishing to attend to a LAN, whether this LAN is wired or wireless. ماشي? The use of 802 can prevent rogue access points and other unauthorized devices from becoming insecure backdoors. So through this authentication, we can admit any device in the LAN, again, whether wired or wireless, right? Therefore, we can prevent any malicious nodes from having access to this LAN. Okay? طيب. So this is part of another standard, and there's nothing new in this slide. This is also to reiterate on the countermeasures. So we can use encryption, but encryption requires key exchange. So we have to do authentication, key exchange, and then we can use the key exchange for encryption. We can use antivirus, anti-spyware software, and firewall. We can also apply these in terms of policies to admit any node to the network. As we said, we have the authentication and key exchange servers, but also we have policy servers, right? So these are done through the policy servers. ماشي? So there are certain policy servers. I can prevent مثلا I can make a list of all the MAC addresses of the nodes that can access this, or I can put some policy that the antivirus should be updated on this node in order to admit this node to the network and so on. So authentication and key exchange, but we have also the policy server. As we said, turn off identifier broadcasting, nothing new here. Change the identifier on your router from the default. Some routers, they come with a default admin. So if you buy a new router, you try first admin, and in most of the time it works. Of course, that's not really secure. So the moment you get your access point, the first thing you should do, or any router at home, the first thing you should do is just to change the default password on the admin account. ماشي? Allow only specific computers to access the wireless or the wired LAN. As I said, you put all the list of MAC addresses that are allowed to access this network. So there's nothing new here. يعني. When it comes to mobile device بقى, يعني this is from the access point of view. Okay? From the mobile device point of view, we also have some security properties. Mobile devices have become essential element for any organization. So the biggest factor in mobile devices is the mobility, is the fact that it's highly mobile. Access points are not mobile, but wireless devices are highly mobile. And not only that, wireless devices are also diverse. So these are the two main features when it comes to mobile devices. They are highly diverse, so they can get from the range of very tiny little nano robot, okay, all the way to a very powerful gaming laptop. And all of them are wireless devices, right? So they are highly diverse, and they move. They can move from one place to another. طيب. Prior to the widespread use of smartphones, network security was based upon clear defined perimeters that separate trusted internal networks from the untrusted internet. As we said that, when it comes to wired network, okay, based on the network access security that we have studied in the previous chapter, the perimeters of the wired network is really clearly defined, both hardware and software. من ناحية إيه بقى؟ When I connect to the switch, I'm part of the network, and the perimeter معناه إيه؟ The domain of the wired network is clearly defined. Anything that's connected to this wired switch will be part of my domain, as long as it's admitted and authenticated. Okay? So there is no fuzziness. There is no gray levels. ماشي? The problem with wireless is that, as we said, we can have accidental association to the wireless network of people outside my perimeter, outside my domain. Okay? So the problem with wireless is that the domain or the perimeter is not clearly defined. It's not a clear cut. Okay? Even you are standing at certain place, at some point you may be able to associate yourself to the wireless network, and in some cases you may not be able to, depending on so many things and the properties of the wireless channel and so on. So the perimeter is not a clear cut in the case of wireless. Also, when it comes to software, the perimeter is not clearly defined. Why? Because in wired, the device is not mobile, it's fixed. If that device connected to this switch, I can admit this device to connect to a specific server, email, or whatever. I can do that easily, right? And I know that this fixed device is trying to access this server from within the domain of the network. Clear, right? The problem with wireless is that this device can access the cloud-based applications. Either a device inside the network can easily connect on Dropbox, مثلا, or Google Drive, or anything outside, and you don't know that this cloud-based application is syncing some information that it gets incorporated or it gets imported into your wireless network easily. This scenario might exist in wired. I can use a workstation to connect to Dropbox. The more common scenario for wireless is that you are traveling, you get your laptop, you go مثلا to US, ماشي, and you stay in a hotel, but you want to access your email, you want to connect on your university's server or your company's network, right? So from this unsecure network, which we don't know anything about, you want to access some servers and services inside your organization. Okay? That might bring some threats, right? So again, that makes your perimeter, again, not confined. It makes your perimeter really fuzzy, really fuzzy. It's not clearly defined. You may get some networks from some devices, some wireless devices, mobile, and from outside. They access some services from inside the university. And in some cases, you have to allow this. Muhammad has to check his email, right? It doesn't work, that I cannot change my email just because of the fact that I'm traveling. Okay? So this clearly defined perimeter is really challenging for the case of wireless. So there is, for the case of wireless, as we said, the massive changes, both on the heterogeneity of the device and the mobility of the device, creates all these scenarios that we have almost never seen before. The growing use of new devices. Even one person, every day he comes to the university with a new device. You may actually carry maybe 10 devices on you, right? Some of them are new, and you need to be able to connect to the university network with all these devices combined. Cloud-based applications, as we said, we can access Dropbox, we can access Google Drive from inside the university, and we don't know whether the information that you have on these cloud applications, when it syncs to your mobile device inside the university, that it does not have any malicious data or something. So there is that concept of deep perimeterization. It's very hard to pronounce this word. Deep perimeterization talks about the fact that, again, there is no clearly defined perimeter in the case of wireless. And there is external business requirements. So just the fact that I'm external to the network, I should be able I have some requirements to be able to access certain services from outside. Okay? But this requires the fact that you connect to your company's network through unsecured network outside. Sometimes you go to a hotel and the hotel network is not even secure. They don't even use any security protocol. But that's what you have. So what do you do? In some cases, you may take the decision to say, okay, so I'm going to connect to the network because I have no other choice. And then you connect to QU from that network, right? So imagine that this is an unsecured network through which you connect to the QU network. So you don't know, or the university command does not know, what are you bringing from this unsecured network to the network of QU. So that introduces loss. What is the reason for that? Is that your device is wireless and it's mobile. So you can take it with you and move anywhere. So that's the reason for this. So the central element of all of these changes is the mobile computing device. It's the mobility and the computational capabilities of this device. So again, these are similar to what we have talked about. There's nothing new here. So the same security threats have been laid out or detailed in this recommendation document or specification document from NIST. Whenever we see SP800 or something, this is NIST-related standards. So again, they laid out the details of all the security threats for wireless, similar to what we talked about before. So again, there is nothing new here. So here, lack of physical security controls talks about the fact that we can leave some of these wireless devices unattended, can deploy it in the environment and leave it unattended, which means that someone can gain physical access to these devices. Again, we talked about this before. Use of untrusted mobile devices. The organization must assume that not all devices are trustworthy. Somebody is coming from outside with some new device, okay? So we cannot assume by default that all devices are trustworthy, right? So we need to have some measures based on which we trust certain devices but not others. ماشي كده؟ Use of untrusted networks اللي هي what we talked about in the scenario that somebody is traveling, unsecure network, untrusted network, but through which we connect to the network of the organization. ماشي? So maybe the device itself is trusted, but the network that this device is connected to is untrusted. واضح الفرق؟ ماشي كده؟ Use of untrusted content, we talked about this regarding the QR code. Again, there's nothing new, it's just a different formulation of what we talked about before, based on this standard. So the standards, they can define certain concepts, but in a different format. ماشي? So use of untrusted content, we talked about this for the case of, again, because of the portability, I can use my device to read QR codes, barcodes, things like that, and get huge amount of content with just a simple click, and get some malicious content as part of this. I can connect to a website. I sensed through a QR code, I sensed some link to a website. I could connect to this website accidentally, and this website is malicious, so I can get harmed. So it is easy use of applications created by unknown parties. It's easy to find and install third-party applications similar to third-party applications like مثلا Dropbox or Gmail or WhatsApp or whatever. ماشي? These are third-party applications. These are not services that this organization provides. This organization مثلا provides the email service, they provide Blackboard, they provide these services, but they cannot disable all types of external services, right? So there are tons of other third-party applications that you should be able to access from your company's network. But again, working on these third-party applications might bring some threats to the organization. So unless an organization interaction with other systems, unless an organization has control of all the devices involved in synchronization can happen مثلا through Dropbox, Gmail, things like that. There is considerable risk of the organizational data being stored in unsecured location. So the synchronization might in fact leak some secure data from the organization to your Dropbox or to a third-party cloud-based application. ماشي? This information can be utilized by attackers or something like this to attack your network, or the other way around. So you are doing some sync with your information from the cloud. It can bring information to your current network that will harm the network. ماشي? So you can sync some Trojans, you can sync some malicious data that can perform any kind of facilitate any kind of malicious attack to the network. ماشي? Use of location services. So an attacker can use the location information to determine where the device is and user are located, which may be used for an attack. So you are moving from one place to another. ماشي? So similar to the fact that when you move مثلا in a mall or something, some people they use location-based services to detect the fact that مثلا you are in this certain location, so they give you or they send you some SMS ماشي based on your location. يقول لك there is a store next to you that has a discount of 70%. ماشي? So you say, يعني, I'm next to it. يعني, how can someone detect? So the fact that your device is mobile, you can detect the location of this device, and based on that, you can post some content to this device based on its location. ماشي? So I can do the same to facilitate an attack. I don't use it for legitimate use like ads, لا, and I use your location to detect that you are مثلا in the perimeter of LAN, a wireless LAN. So I send you something that once you read it, I can gain access from this LAN because I know مثلا this access point has lack of security مثلا. So I detect the fact that you are in this location and send you some content that gives me an access through your device to this LAN and then to the network and so on. So I can use it for attack. يعني. I can use this information of the fact that I know your location to facilitate the attack. ماشي? So location can also be used as a piece of information to facilitate the attack. So there's nothing new in this. This is the architecture, which is again similar to the network security architecture. We have the components, we have the authentication server. ماشي؟ أو احنا سميناه ايه فاكرين؟ radius server. ماشي؟ So we can have the authentication server or the radius server. We have the policy servers, which could be mobile device configuration server, okay, or firewall. Through these servers, we enforce certain policies. ماشي? Like مثلا antivirus should be updated. مثلا password should have a certain format. ماشي? Through this mobile configuration server or firewall, we can enforce some policies. ماشي? And we have the application or the server, the service server, whether this is مثلا email, database, Blackboard, anything. ماشي? The dynamic thing or the modification in the case of wireless comes here, as we said, that this device is highly heterogeneous and mobile. ماشي? So I can connect from anywhere, inside or outside the perimeter of this wireless LAN. ماشي? I can connect with any access point based on my location. Hence, if one access point only has lack of security, I can use that as an entry point to attack the entire network. ماشي? So this architecture again is not new. We talked about it in network access security, except that here the main change comes in the access point and the wireless device. The wireless device itself is highly diverse and highly mobile, and the access point itself has to perform a discovery and an association. And we will talk about these phases in the upcoming slides in more details. طيب. So until now, as I said before, the map of this chapter is divided into 3 major sections. The first section, which is what we covered so far, we talked about the wireless related properties that introduces more threats in the wireless domain that have not been encountered before in wired networks. Okay? So until here, you should come to the perception and conviction, hopefully, that we have to deal with wireless differently. ماشي? Why? Because of the يعني exclusive properties in wireless, which is for the case of mobile device, it's related to the diversity, it's related to the mobility, and for the case of access points, related to the discovery phase and related to the association phase and all of this, which again did not exist in wired, and that introduced lots of new threats. ماشي كده? This part, starting from this slide, talks about what are the wireless standards, okay, that exist now and some terminology about wireless. ماشي؟ يعني from here, this should be taught in a wireless course, not security. This is not related to security. This part is not related to security, okay? In the third part, we will talk about بقى إيه؟ اللي هي security protocols over wireless. But now we need to understand the wireless domain, how it looks like, and what are the terminology used for the case of wireless. We'll talk about some definitions for the case of wireless that we have not been introduced to, at least in Network 1. If you have taken Network 2, maybe some of these you have been introduced to. ماشي? Any course in undergrad related to wireless, you should, this should not be a new thing to you. ماشي? طيب, for the case of wireless, they started the case, they started the development of wireless standards back before مثلا 1990 وكده. They started with the first standards اللي هي 802.11. So there is a consortium or a standard group ماشي. They worked on the development of the first standard, which is 802.11b. No, the first one ماشي. So they said that to facilitate wireless devices to connect to wireless LANs and stuff like that, 802.11b can give you مثلا a throughput of حد عارف throughput 11 megabits per second, not more than this. ماشي. Now with Bluetooth we can get the same data rates. But they said here this is the standard. What happened after this was really shocking, because they found the fact that people were extremely thirsty to adopt wireless standards. They did not expect this to happen. So in 1990, the amount of vendors that implemented these standards, and they have actually modified these standards to provide products and applications, was beyond anyone's expectation. The adoption of this 802.11b was beyond anyone's expectation. Okay? So the adoption was really exponential. So since then, the demand for wireless LANs at different frequencies and data rates has exploded. They did not expect this to happen. So we have to do it the right way. So what happened is that they said no, let's do it the right way. So they formed a big consortium, huge consortium. They brought all the vendors that tried to adopt these wireless technologies or wireless standards in their products. And the standard group, with these vendors, they have formed a big consortium. اللي هو بيسموه ايه Wi-Fi Alliance. اللي احنا بنعرفه اللي هو Wi-Fi Alliance. They formed a big alliance to develop Wi-Fi standards. ماشي? So they started to develop 802.11b. So after this, 802.11g, and then A, and then AC, and then N, and then I, and then E, and all of these they came about through this Wi-Fi alliance. So this is the historical story of this. ماشي كده? So what we need to discuss now is that what is the jargon? What are the terminologies or the basic definitions that they have defined in these standards that we need to be aware of, okay? Because we need this when we talk about the security services related to wireless. ماشي? We have to do بقى ايه? So some of these basic concepts, they defined what access point is. Access point is an entity that station functionality that has station functionality and provides access to the distribution system. So what is distribution system أصلا? So that's the definition of a distribution system. So basically we have a graph in the next slide that shows everything. And once you see the graph, it becomes very easy. So we know the access point. The distribution system is the back network that this access point is connected to. ماشي كده؟ واضح كده؟ طيب. So there is a basic service set. Basic service set is basically يعني what we have known to be the wireless LAN. اللي هي it's a group of stations controlled by an access point. ماشي? So if you have a group of stations connected to one access point, only one, ماشي? We call this a basic service set. واضح؟ طيب, this is a logical definition. What is the coordination function بقى? The coordination function is a functionality that works mainly on the access point. ماشي? But it doesn't necessarily have to work on the access point. It may actually work on any server in the distribution system. But this is a logical function that determines when a station operating within a basic service set is permitted to transmit and may be able to receive. يعني, this is the one that admits, again, not from the security perspective, only from a communication perspective. يعني, this station is now, it wants to associate itself to this access point. Can it actually send information back and forth or not? Regardless of whether there is a security or not. ماشي كده؟ Should it be able to send? We call this حد فاكر ال PDUs? Network 1, no? فاكرين اختصار ايه؟ حد فاكر؟ Protocol data unit. Protocol data unit, we call the format of the message in any layer, we call it a protocol data unit. Protocol data unit is defined by a header and a body. صح؟ فاكرين؟ In every single layer in the layered stack, we talked about a specific protocol data unit, right? Protocol data unit in network access layer, we used to call it a frame. In network layer, we used to call it packet. In transport layer, we used to call it segment. Eh? Segment. Bravo عليك. Yes. Right. ماشي? So each of these, it's composed of a header and a body. The body, we call it service data unit. The body, we call it service data unit. So this is a protocol data unit. It's a header plus service data unit. We used to call this the data. Here we call it service data unit. ماشي كده؟ Okay. طيب. So the distribution system is the system used to interconnect the basic service sets. واضح؟ So multiple access points, ماشي, are connected through a back-end network. We call it a back-end network. This back-end network could be wireless or wired. But mainly it's wired. ماشي? And there is the extended service set. The extended service set is the interconnection of all the basic service sets through the distribution system. When we see the graph, it will become very easy. So there is a protocol data unit and service data unit. We talked about this. So this is what the graph looks like. So once you see the picture, it becomes very easy. So this is a basic service set. This is a basic service set. This is a distribution system. So any communication, so this device can talk to this device, but it has to go through this access point, then the distribution system, then this access point, then this device. It has to go this way, even though they are next to each other. شايفين? Yeah, they are very close to each other, but there is no ad hoc communication. If they want to talk to each other, they talk not by using Wi-Fi standards. They use Bluetooth ولا حاجة. But this is outside of our scope. ماشي? So all the communication has to happen through access points. There is no ad hoc. يعني these devices, they are not allowed to communicate with each other without the access point. So this has to communicate to the access point, and then from the access point to the device. لازم كده. ماشي? طيب, this is the basic service set. This is the basic service set. this whole thing is extended service. واضح كده؟ في أي confusion؟ طيب فthis is about the story of the wireless اللي هو Wi-Fi Alliance. So the standard to gain broad industry acceptance was 802.11b. دي اللي عملت الاكسبلوجن كله بقى. Okay? This caused يعني huge explosion of adoption that they did not expect this to happen. فالوايرلس Ethernet Compatibility Alliance اللي هو الويكا, this is the standard group that started the development of 802.11b. They said no, it doesn't work this way. يعني the explosion of adoption requires بقى some unified agreement. So they formed a big consortium. They called it بقى Wi-Fi Alliance. So the WICA became the Wi-Fi Alliance. They incorporated lots of vendors that tried to adopt the initial specifications of 802.11b, and they formed a big consortium of Wi-Fi Alliance. Later on, this consortium developed lots and lots of standards, starting from 802.11g, A, N, I, E, يعني AC, many of them. ماشي? Whenever we see Wi-Fi 5, Wi-Fi itself talks about the term used to certify a certain standard. So anyone who comes up with an implementation, we should certify and verify that this actually aligns with the standard. We know that the standard alignment, that يعني, in order to conform with the standard, you have to have certain elements in your implementation. تمام؟ Wi-Fi 5 talks about the standards. انتوا عارفين الفرق بين between 802.11g B and 802.11a? Anyone knows the difference? This depends on the range of frequency. So 802.11b and G, they use a range of frequency اللي هو 2.4 gigahertz. 802.11a was standardized, yes, with the motivation that there is a lot of interference in the 2.4 gigahertz range, so we better go in a range that's not completely occupied. ماشي? They came with the 5 gigahertz. Of course, in 5G now they go to terahertz with 5G. So every time they have contention on a frequency range, they go to another. ماشي? So Wi-Fi 5 talks about the standards in the 5 gigahertz. واضح كده؟
Now I think there is Wi-Fi 6E.
ممكن
With the 6 gigahertz.
With maybe عشان to align with the 5G standards, they use 6. Actually, they use 6 terahertz. They وصلوا ل 6 terahertz, not gigahertz. They call it millimeter wave for the case of 5G. So anyway, recently Wi-Fi Alliance has developed certification procedures for 802.11 security. So with the evolution of the standards 802.11g, the first 802.11b came with the same standards of اللي هم بيقول it WEP, wireless equivalent privacy اللي هو الويب. ماشي. Later on 802.11g, they found some security drawbacks, security pitfalls in web, so they came with WPA. But this is what we are going to study in the third part of the chapter. So we'll study the difference between web and WPA and WPA2. So we're going to study that in the third part of that chapter. خلاص كده? So we'll stop here.